So now we're going to talk about the derivative of a product, which is known as the product rule. The first thing that I want to stress is that you cannot simply take the product of the derivatives. So a formula of this type, that the derivative of f times g is equal to f prime of x times g prime of x, is completely false, and you should avoid it at all costs. Okay? What is instead the correct formula? Well, it's more involved than this, and it's the following. So the derivative of f of x times g of x is equal to f prime of x times g of x, not differentiated, plus f of x, not differentiated, times g prime of x. And now we're going to prove why this formula holds by using the definition of the derivative. So let's erase this abomination and slide this over. Alright. So once again, we start from the definition of the derivative. So what is the derivative of f times g? By definition, this is the limit as h approaches 0 of, now if the product computed at x plus h, so this will be f of x plus h times g of x plus h, and then minus the product evaluated at x, so f of x times g of x, all divided by h. Now here it seems that there's not much that we can do, and therefore we're going to use a trick. So the trick is as follows. In the numerator, I'm going to add and subtract a same quantity. Okay, so in particular, I will subtract f of x times g of x plus h. Clearly I cannot just subtract whatever I want. If I do that, then I also must add the same quantity so that I don't change my expression. Okay, in this way I subtracted and added the same, so it's like I'm just adding 0, which doesn't change the fraction. And then I have the other term, f of x times g of x, all divided by h. And now we're going to group together these two and these two. So what do we get? We still have a limit as h approaches 0. Now, if I group together these first two terms, they have in common the factor of g of x plus h. So I can factor this out, g of x plus h. And then from the first term, if I take out a g of x plus h, I will be left with the term f of x plus h. And then from the second, I have a negative f of x. Okay? Now I have plus, and if I look at the second terms in green, what I can factor is f of x. Then I open a parenthesis, and from the first term, I will be left with g of x plus h. And from the second term, I have a negative sign, and then g of x. So minus g of x. Again, everything divided by h. So now I separate the fraction into the sum of two different fractions, and I use the fact that the limit of the sum is the sum of the limits, as we did before many times. So this turns out to be the limit as h goes to 0 of g of x plus h times f of x plus h minus f of x divided by h. and then plus the limit as h approaches 0 of f of x times g of x plus h minus g of x divided by h. And now we're going to compute these limits. So here I have the limit of a product, so let's look at the limit of the factors. So when h goes to 0, these terms converges to g of x, while this term converges to f prime of x by definition of the derivative. And now if I look at the other side, well, this term f of x is independent of h, so when h approaches 0, this just converges to f of x, while this fraction, by definition, when h approaches 0, converges to g prime of x. And therefore, if I combine what I just said, so here, these two limits are both finite, so the limit of the product is the product of the limits, and I get g of x times f prime of x. Then I have plus, and here again the limit of the product is the product of the limits because they are both finite, so f of x times g of x. And this is precisely the formula that we wanted.